forced air system airflow rate, fan watt draw, and determination of fan efficacy. So these are the references for this particular section. It's going to be reference appendices in section RA 3.3. And again, that's the link where you can download the actual document, or you can also download it from the LMS. Improved system airflow rates, or CFMs, and reduced fan power and watt draw is achieved through improved air distribution system design, including more efficient motors and ducts that have less resistance to airflow. These designs and verification criteria are applicable to ducted, split, and packaged space conditioning systems serving low-rise residential buildings. Determination of fan efficacy, watts per CFMs, utilizes simultaneous measurement of air handler fan watt draw and airflow rate. So basically, the purpose of this test is to make sure that the systems are not using any more energy than they have to per CFM being produced by the actual system. So the overall training goal is to gain an understanding of forced air system airflow rates, fan watt draw, and determination of fan efficacy testing equipment, protocols, and forms. And these are the sections that we're going to be covering in this particular PowerPoint. So let's go over the equipment specifications first. Just like everything else, we had equipment specifics that we have to use and certain type of equipment that we can or cannot use, and this will be covered. Pressure measurements shall be measured with equipment having an accuracy equal to or better than plus or minus 1% of pressure reading, or plus or minus 0.2 pascals, whichever is greater. All pressure measurements within the duct system shall be made with static pressure probes such as a Dwyer A303 or equivalent, and that's the picture of a sample probe. And these are the same probes that we talked about earlier when we were talking about duct flow and airflow. Airflow rate measurement shall be made with an airflow rate measurement apparatus, which is the sensor plus data acquisition system, having an accuracy of plus or minus 7% of reading or plus or minus 5 CFM, whichever is greater. On the left-hand side, you'll see the 4 different pieces of equipment that you can use to measure airflow. On the top left-hand side, you'll see the duct blaster, which I've covered for the purpose of the duct blast in the previous section. Nonetheless, the duct blaster can also be used to measure airflow for this particular test. On the top right-hand side, you'll see the flow grids. On the bottom left-hand side, you'll see a powered flow hood. And on the bottom right-hand side, you'll see a regular flow hood. We're going to be covering the procedures on how to measure the airflow with each one of these pieces of equipment. Fan watt draw measurements shall be made with true power measurement systems, i.e. sensor plus data acquisition system, having an accuracy of plus or minus 2% of reading or plus or minus 10 watts, whichever is greater. And on the right-hand side, again, there are 2 different types of equipment that you can use. Now, the piece of equipment on the left-hand side, that's the kind of meter that you would use when you have a hardwired system. If you have a hardwire furnace, obviously you're not going to be able to unplug it and plug in a watt meter into it. So by hanging that meter on top of the line itself, you're going to be able to take a watt reading off of it. On the right-hand side, that is a plug-in watt meter. And those are for units that are actually plugged into an actual outlet rather than being hardwired into the house. And for those, obviously, you can unplug it, plug the meter into the outlet, and then you plug the unit into the meter and taking a watt reading that way. Either way, they're both approved for use. As I mentioned a couple of slides ago, the system airflow rate shall be measured using one of the following type of apparatuses. So we have the fan flow meter, which is the duct blaster, the flow grid, the traditional flow capture hood, and a powered flow capture hood airflow measurement device. We're going to be explaining how to collect the data with each one of the systems once we actually get to procedures. So the first one is the fan flow meter or the duct blaster. So it shall consist of a duct pressurization and flow measurement device and a static pressure measurement device meeting the specification as previously described. On top, you'll see the Minneapolis. The bottom, you'll see the Retrotec, just like the duct blaster systems that we discussed in the duct leakage section. The airflow grid shall consist of an approved flow grid and a digital pressure measurement device that meets the specifications as previously described. So in this particular case, you're looking at the Minneapolis or Energy Conservatory flow grids. The flow grids are very specific in the type of equipment that they are. The manometer that you see in the picture is the same manometer that's also used with the duct blaster. So the duct blaster manometer is used with a variety of different equipment. Here we have a traditional flow capture hood. It shall meet the applicable instrumentation specifications previously described, and it may be used to verify the system airflow rate if it has a capture area at least as large as the system grill in all dimensions. So basically what that means is the fact that the top area of the flow hood has to be able to completely cover the return grill that it has to cover, that's going to be measuring. If it doesn't, you either have to build or buy an adapter to make sure that the flow hood will cover completely the return grill that you're testing. The powered flow capture hood airflow measurement device is a device that has the capability to balance the flow capture static pressure difference between the room and the flow capture hood enclosure. It meets the applicable instrumentation specifications as previously described. It may be used to verify the airflow as long as a flow capture area at least as large as the system register grills in all dimensions, just like the traditional flow hood. The fan adjustment needed to balance the flow capture static pressure difference shall be provided by either an automatic control or a manual one as well. So as you can see in the picture on the left hand side, that is actually a duct blaster fan with the same manometer with an additional attachment piece used specifically for this particular test. For watt draw, the watt draw measurement shall be measured using one of the following types of apparatuses. You have a portable watt meter, an analog or the analog utility revenue meter, or the digital utility revenue meter. The portable watt meter shall consist of a watt meter meeting the applicable instrumentation specifications as previously described, and we talked about this in a couple of slides ago. The analog utility revenue meter shall consist of a utility revenue meter meeting the applicable instrumentation specification as previously described and a stopwatch that provides measurements in units of seconds. And you'll see what you need the stopwatch for once we actually get to the procedure. The digital revenue utility meter shall consist of the digital utility revenue meter meeting the applicable instrumentation specifications as previously described that provides direct digital display of the watt draw.